Here we're going to take a look at graphing the inequality x plus 4y is greater than 8. The first thing we have to do when we're graphing inequalities, just like equations, is getting them in the slope-intercept form. So I'm going to start by subtracting x from both sides. So I get 4y is greater than negative x plus 8. Then to isolate the y, I'm going to divide everything by 4. So y is greater than negative 1/4 x plus 2. So my slope is negative 1 over 4. My y-intercept is equal to 2. So my graph, we're going to start at the y-intercept, which is 2, and we're going to plot a point. Then I'm going to use my slope, which is rise over run. I'm going to rise negative 1. I'm going to run 4. So I'm going to go down 1 over 1, 2, 3, 4. Put a point on the graph. 1, 1, 2, 3, 4. Put another point. And I'm going to continue to do this to the end of both ends of the graph. Then I'm going to go up 1 and back 4 from the original point. 1, 2. So I have points in both directions to both ends of the graph. Now I'm going to take a look at my inequality. So my inequality is a greater than. So if I have a greater than or less than, if I have a greater than or a less than, without the equal to, these are going to create dashed lines because we don't want to include that value in the graph. So we're using a dashed line to indicate that it's everything beyond the line, but not the line itself. If I had a greater than or equal to or less than or equal to, it would be a solid line, indicating that we're including the line in the graph. So in this case, like I said, we have a greater than, so we're going to create a dashed line through those points. So that the solutions are not included on the line, or the line's not included in the solution set. Now I'm going to take a look at the inequality again. So I have a greater than. If I have a greater than, we're going to shade above the line. If I have a less than, we're going to shade below the line. So in this case, it's everything greater than that line. So for this problem, we're going to shade everything above that line. That's where my solution set is. Every ordered pair inside that red region is part of my solution. So for instance, if I pick the point, let's say I pick the point 2,5, is it a solution to my inequality? So I go over 2, up, 1, 2, 3, 4, 5. The point is right here. It is inside the red shaded region, so that would be a valid solution. So yes, it's a solution. If I pick a point such as 4, 1, I go over 1, 2, 3, 4, up 1. It is on the dashed line. We said nothing on that dashed line is included in my solution set, so that would not be a valid solution. And if I pick something like 4, 0, it is right here on the x-axis. It is not part of the line or the red region, so it would not be a solution either. So we first start out by graphing the line using the same methods we used to graph a slope-intercept equation. Then we determine whether it's a dashed line or a solid line based on whether or not the inequality sign has an equal to. And then we look at the inequality. Is it greater than? We shade above the line. Is it less than? We shade below the line. And then we determine our solutions based on, do they fall within the shaded region? And the last thing, if this was a solid line and I picked the order pair 4, 1, so I picked this one right here, picked the order pair 4, 1, and it was on a solid line, then that would be a valid solution if the line was solid. But since it's dashed, in this case, it is not.